Hi everybody. On today's show, we solve linear equations by using the addition and multiplication properties of equality. So we learned about these properties in lesson 1, and they basically say I can add the same number to both sides and I don't change the solution set, and I can multiply both sides by the same number and I won't change the solution set. And this should mostly be review from 8th grade and 7th grade solving of equations, but it's good for us to spend a day on it because it's an important skill to have. Verify that x equals 8 is a solution to the equation here. So take a second, pause the video, and see if you can verify that x equals 8 is a solution. So how do I check that something is a solution to an equation? Well, before I solve it, to just check that it's a solution, I can plug it in. So wherever I see an x, I'm going to replace it with an 8. And I want to know, do I get a true statement or a false statement? 5 times 6 minus 6, does that equal 24? Well, is 30 minus 6 equal to 24? Last time I checked, it is. So, yes, x equals 8 is a solution. X equals 8 is a solution. Why? It makes the equation true. Using our properties of equality, we can isolate our variable. We can use inverse operations. Inverse operations are really essential to what we do in mathematics. So you should pretty much know that the inverse of adding something is subtracting something. The inverse of multiplying is divided. Those are inverse operations. To undo subtraction, I add. To undo division, I multiply. So using these inverse operations, we can solve for the variable if it shows up once. The key thing is the variable can only pop up once for this technique to work. So let's see how we can use this to solve this equation here. So I have 5x plus 3 equals 23, and I want to know what number for x makes this true. What number, when I plug it in for x, makes this a true statement? Well, what's happening to x? Let's identify what are we doing to x. Well, first, we're multiplying it by 5. Right? Here's x. I make it 5x by doing 5 times x. That multiplication comes before that addition there. And then we add 3. That's what happened to x. I want to undo that. I want to get x by itself by working our way backwards. Think about your socks and your shoes. First you put your socks on, then you put your shoes on. If I want to undo that, the first thing I have to get rid of is not my socks. I have to get rid of my shoes first. So I need to undo adding 3. How? By subtracting 3. But the addition property of equality says I can subtract 3 from both sides. Those add to 0, and I end up getting 5x equals 20. So we got rid of the adding 3. How do I get rid of multiplying by 5? Well, I don't care about 5 times x. How do I undo that multiplication? I divide by 5 and get x equals 4. X equals 4 is our solution. How do you check it's a solution? Plug it on in. Let's slide on down to the next one here. Let's look at this one right here on the left-hand side. I have x minus 3 over 2 plus 7 equals 23. So here's x. What's the first thing that I'm doing to it? Look at this left-hand side here. What's the first thing I'm doing to x? It looks like I'm subtracting 3. Then, once I subtract that 3, it looks like I'm dividing that whole quantity by 2. And then once I divide that by 2, I take whatever number I get there and add 7. So to solve this equation, we're going to work our way backwards. We're going to use inverse operations to work our way backwards. So the first thing that's got to go is I got to take off my shoes first. I got to get rid of that adding 7. So I'm going to subtract 7 on both sides. X minus 3 divided by 2 is the same as 16. Well, I got rid of the add 7. Now, how do I undo this division by 2? How do I undo dividing by 2? I multiply both sides by 2. Those divide to 1, and I'm left with x minus 3 equals 32. And finally, I don't care about x minus 3. How do I undo that subtraction that's occurring? Well, to undo subtraction, I add. I use the addition property of equality to make that 0. And I got x equals 35 as my solution. 35 is the number that makes this a true statement. So slide back up here, pause the video, and see if you can work on solving these two equations. Hopefully you found this successful. Here's x. I'm multiplying by 8, then adding 2. So let's subtract that 2 over, and I get 8x equals negative 4. And then I don't care about 8 times x. I need to think of how do I undo multiplication. I divide. And I get x equals negative 1/2. That is my solution. Over here, this one has the same structure as these past two. 5 times x plus 12 equals 87. Well, here's x. I'm multiplying it by 5 and then taking that thing and adding 12 to it. So let's undo the plus 12 by subtracting 12. 5x equals 75. I don't care about 5 times x, so I'm going to divide to undo that multiplication there. X equals 13. Just kidding, not 13, 15. Should check that on your calculator to be sure that I'm right. So let's look at this equation here. And I know it's so tempting to distribute, but let's not distribute right now. Let's not distribute and see what's happening to x. I know you really want to distribute that 4 in, but put the brakes on for a second. Don't distribute. Here's x. Let's list out what's happening to it. Well, what's the first thing I do to this x? Do I multiply it by 4? No, I deal with what's inside the parentheses. The first thing I do is I add 1. Then what do I do to that chunk there, that green circle? We multiply that quantity by 4. You could distribute and you're going to get the right answer, but I want to practice not distributing right now. So now I have that 4 times that, and then I subtract 2. So we've got to work our way backwards to do the inverse operations there. So how do I undo subtracting 2? I need to add 2 to both sides. And I get 4 times x plus 1 equals negative 4. I need to get rid of that multiplying by 4 by dividing by 4. X plus 1 equals negative 1. Well, I don't care about x plus 1. I want to get rid of that plus 1 there. So I'm going to use the addition property of equality and subtract 1 from both sides. That becomes 0. I get x equals negative 2 as my solution. So could you have distributed and gotten the right answer? Absolutely. I just wanted to practice that you don't always have to distribute. I know in 7th and 8th grade you were told distribute, 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 distribute. You don't have to all the time. Most of the time you will have to, but in some cases you don't need to. Equations can be solved in multiple ways, as we were just talking about this. Let's solve this equation in 2 different ways. So I know you want to use it so badly, so let's distribute. Let's use the distributive property here to solve this equation. I see this relationship here. I'm multiplying over that subtraction, so I'm going to distribute. Negative 2 times x is negative 2x. Careful here. Negative 2 times negative 4. It's not just a 4, it's negative 2 times negative 4, which gives me a positive 8. Plus 8 equals 2. So that was my distribution there. Then I'm going to combine my like terms on the side. Well, how do I get x by itself? Well, it looks like I need to subtract 16. Negative 2x is equal to negative 14. Well, I don't care about negative 2 times x. I want x all alone. So let's divide by negative 2. I get x equals 7. X equals 7 is the solution to that equation. Now, let's use inverse operations, and I can use inverse operations because there's only one x. So let's see what the operations were here. Well, here's x. What did I do first? It looks like I subtracted 4. So that gave me that chunk. And then I multiplied by negative 2. It gave me that, and then I added 8. So let's use inverse operations here, and hopefully we better end up at x equals 7. Well, we have to work our way backwards. Let's undo adding 8 by subtracting 8. Negative 2 times x minus 4 equals negative 6. How do I undo multiplication? I undo multiplication by dividing. X minus 4 equals positive 3. Well, I don't care about x minus 4. I want to undo that subtraction by adding. and get x equals 7, which is good because that's what we got when we applied the distributive property. So this is just showing us there's more than one way to solve an equation sometimes. Sometimes you can distribute, sometimes you can use inverse operations. It doesn't matter in most cases. This row of equations looks absolutely horrendous. And it looks horrendous because there's fractions, and that scares us. But it shouldn't. It shouldn't scare us because we just need to think about that denominator of a fraction as division. So let's look at this first one here. I have 2/3 x plus 5 equals 1. So I'm going to solve it two different ways. Let's get x alone. How do I get x alone? Well, that plus 5 has got to go. So let's subtract that 5 over. So I have 2/3 x equals -4. Think about this fraction in two different parts. That denominator is really telling me it's division. How do I undo that dividing by 3? Multiplying by 3. So I have 2 times x equals -12. And now there's not a fraction, and I'm not so scared. 2 times x, well, I don't care about 2 times x. I want to get x alone, so I'm going to divide by 2 to undo that multiplication and get x equals -6. Not bad, not bad. Try this next one on your own. Pause the video and see if you can solve this next equation on your own. Hopefully it went well. Let's see how you did. So I need to get this x alone, and there's some multiplication here, but that 7 is just hanging out. That 7 has nothing to do with that x. So let's undo that 7. Well, it's a positive 7, so we'll subtract 7 to make it 0, so it goes away. 6 equals -3/4 x. Well, I don't care about -3/4 x. Let's kind of think about this in a different way. Don't think about it as a fraction. Think about it as two different operations. I'm dividing by 4. How do I undo division by 4? I multiply by 4. So I have 24 equals -3x. Well, I don't care about -3x. That's -3 times x. I'm going to divide to undo that multiplication. X is equal to -8. This next one looks even like more fun. We got a couple places to start. I know what you really want to do is distribute, so I'll go ahead and let you do that. I'll go ahead and let you distribute there and see what you get. So let's distribute that 14/15 in because I know that's what you want to do, and that's probably what you would do if I wasn't with you here. And I get 14/15 x plus 126 over 15 times 28. I'm just doing this on a calculator here to get it right. Over 420 equals 8. Well, that's hideous looking. So let's think about how do I get x by itself. This equation here has the exact same structure as these baby two-step equations that we started back here in question 1. It has the exact same structure, so we're probably going to be following similar steps to solve it. Let's get this x term all by itself. So how do I do that? I subtract over this ugly fraction here. I subtract over both sides by 126 over 420, which can be simplified. So I have 14 over 15x equals 8 minus the fraction 126 out of 420. And my calculator is telling me that's 7.7. You can write that as a fraction, or you can leave it as 7.7. Now, how do I get x by itself? Think about this fraction in two different steps. I'm dividing by 15, so let's multiply by 15. Let's take our 7.7 there and multiply it by 15 and see what we get. I have 14x equals 115.5. And finally, I don't care about 14x, so I'm going to divide by 14 because that will isolate that x for me. And I end up with x equals 8.25. That is my solution to this Beautifully looking equation here. Now you could have done this with inverse operations, and I challenge you to do that on your own and see if you can do it. You wouldn't distribute first, you would multiply by 15 to get rid of that 15 there, but try it. See if you can do this with inverse operations on your own, but you'll know if you got it right by ending up at 8.25. One more equation. Solve this equation multiple ways. Be ready to share. So I'm going to only solve it one way for the sake of this video, but there's a plethora of ways you could have gone about solving this equation. I'm going to use inverse operations to emphasize that. Some of you may start by distributing. I don't know what you're going to do, so I'm going to take the guess that you distributed, and then I'll use inverse operations from there. Don't do what I just did. Rookie mistake here. Rookie mistake. It's late at night. That's why I made that mistake. It's 5 times x. I'm distributing it. Minus 5 times 3 is 15. Over 8 plus 2 equals 7. So here's x. Here it is right there. What's happening to it? Am I dividing? What's happening to it first? Well, it looks like it's getting multiplied by 5. Then, what did I do to that 5x? Am I dividing? No, it looks like I'm subtracting 15. Then what am I doing to that there? I'm dividing that whole chunk by 8. So we're dividing by 8. What am I doing to that whole division expression with division there? I'm adding 2. So let's work backwards to undo this if we're using inverse operations. So I'm going to subtract 2. And get 5x minus 15 over 8 equals 5. How do I undo that division? Now I need to undo that division. We undo division by multiplying. 5x minus 15. And what says I can multiply both sides of an equation by the same number and not change the solution set? That's that multiplication property of equality. How do I undo that subtracting 15? I add 15. 5 times x equals 55. I don't care about 5 times x. How do I undo multiplication? I divide. And I end up with x equals 11 as my solution. And there's no reason I get this wrong because I can check it. I can check that x equals 11 is actually the solution. There's many other ways you could have solved this. Maybe you didn't distribute at first. That's actually probably a faster way to do it. But hopefully this was a kind of new, but kind of a review of solving linear equations. We'll see in the next video when we keep on solving linear equations, but when there's variables everywhere and not just the one that we've been working with.